Good evening, sir. Sir, your voice is not audible.
Good evening, sir.
By class cancel.
Good evening, all of you.
Good evening,
evening,
sir.
Good
Yeah.
evening, sir.
Good evening, Asma. Good evening.
Chilla.
You came early. Good. But morning you are not coming. Why I don't know. Yogita, good evening. Yogita, you are
Good
absent.
evening, sir.
I think you are absent morning and yesterday.
Yes, sir.
Why? Why you are
Sir, there are some family functions, so I am busy.
okay, okay. Doleshwar, good evening. Doleshwar,
Good evening, sir.
good evening. Rohit, good evening. Vinila, good evening. Right. So I think maybe slowly the students will come, but this is very, very important session. See waves. So brief revise for all. Pawan came. Pawan is there. Yeah.
Yes, sir.
Pawan, good evening. I think Anish didn't came.
Good evening, sir.
Anish is absent, I think. Okay. So Anish is absent. Okay. So here you see from beginning onwards. So we can see from beginning onwards. So from beginning onwards, we can check the waves motion. Wave motion you can see. So this is the first chapter. I think this is the chapter name. What do you mean by the wave? What do you mean by the wave? Everything we have written here. So characteristics of the wave motion, I think. So here characteristics of the wave motions are there. So these are the characteristics of the wave motion. Okay, so these are the characteristics.
Yes,
Okay.
sir.
Right. I think now wave should be how the particle will vibrate. So that also they have given longitudinal waves and transverse waves. See, these are the transverse waves in the rod. They create compressions, crust and trough. The successive distance between one crust and a trough is called wavelength lambda. The successive distance between one crust and trough is the wavelength lambda. So the successive distance between the crust and trough is the wavelength lambda. So this is the successive distance between one crust and one trough. The successive distance between one crust and one trough will give you the wavelength lambda. Okay. So now
Yes, sir.
longitudinal waves they have given. See. So what are the longitudinal waves? So that they have given. So longitudinal waves are there here. Wait. So longitudinal waves are there. So longitudinal waves are there. So longitudinal waves. What do you mean by the longitudinal waves they are given? See longitudinal waves. Particle. See here. If the particles of a medium vibrates in the direction of wave, motion, then those are the longitudinal waves. Longitudinal waves creates compressions and rarefactions. Longitudinal waves creates compressions and rarefactions. Examples for sound waves in longitudinal waves. Through air, longitudinal waves. Okay. So these are the longitudinal waves. Now one-dimensional wave motion is there. See, they have given this is wave equation. See, one crust on a trough will give you wavelength lambda. Okay, right. So next, so this is a frequency, time period, everything they have given. Sound waves. So sound waves order is audible frequencies 20 Hz to 20 kHz, 20 Hz to 20,000 Hz. So that is the audible frequency, and ultrasonic wavelength is greater than 16.6 meters. Okay, infrasonics is greater than 16.6 meters that they have given. For ultrasonics, it is less than the 1.66 centimeters. 1.66 centimeters. This is also very important. Wavelength of ultrasonics. Please note down, wavelength of ultrasonics is lambda is less than 1.66 centimeters, and infrasonics is means less than 20 Hz. That is, yeah, so 16.6 meters.
Sir, can you explain the infrasonic waves?
Which one?
Infrasonic waves.
Ultrasonic waves means greater than 20,000 Hz.
Infrasonic waves, sir.
Frequencies greater than or equal to greater than 20,000 Hz, frequency. Lambda is equal to V by N, you can write. So V means in 330 in 330 meter per second divided by 2000 you take 20,000 you can take. Do it, I think you will get that is 16.6 meters for ultrasonics. For ultrasonics, you see less than 1.66 centimeters you will get. Cancel all these things. This is less than 1.66 centimeters. For infrasonics, you take 20. Then you will get this value. Any doubt?
No, sir.
Right. For ultrasonics, you take like this 20,000. For infrasonic, you take lambda if you want to use, that is 330 divided by 20. So that is 16.6 meters. See, 16.6 meters. This is the infrasonic. Any doubt?
No, sir.
Right. Next. This Mach number is nothing but velocity of source divided by velocity of sound. Mach number is nothing but velocity of source divided by velocity of sound. That is the Mach number. That is the Mach number. And here wavelength range they have given for sound waves are 1.6 centimeters to 16.5, means audible frequency, that is 20 Hz to 20,000 Hz. 20 Hz to 20,000 Hz. Any doubt?
No, sir.
In angstroms, 4,000 angstroms to 2,000 angstroms. In angstroms, very important points these are. Audible range wavelength is this one, and wavelength in terms of angstroms, this is 4,000 angstroms to 2,000 angstroms. Okay, right. Next. These are the important things. What I have written here is very important. Please take speed of transverse wave motion. Speed of transverse wave motion. Very important. This you take, all of you. On structured string, you write, all of you please write. On structured string, 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 V is equal to root over T by M. What is T? Tension. What is M? Linear density. Already explained. Linear density. Tension and linear density. Already explained this one. If you want, miss, again, if you want, miss, I will explain this one. You see, this is a tension. T is equal to MA. That is equal to M into V by T. You do one thing. You divide with length and multiply with length. Divide with length and multiply with length. So again, this L by T will give you velocity, and this M by L will give you the linear density. Linear density. Therefore, V square is equal to T divided by linear density rho L. They have given this rho L is equal to M. Actually, that is rho L. So that is V square. This implies V is equal to root over T by rho L. This I have written already in meter per second. Any doubt, please ask me.
No, sir.
Right. Already explained that.
Yes, sir.
So already explained. So I think this pen stroke size is okay, right. So this is the answer. Okay, right. So tension in the string and linear density. Have you completed? Now
Yes, sir.
in solids, that is V is equal to Y by rho or eta by rho. Eta is the modulus of rigidity or Young's modulus, like this also. How you write that equation? Here I have written, you see. I'll write that equation, you see. That is how I have getting this one. You know, the Young's modulus. Shall I write here? The Young's modulus. Here I have written, you see, Young's modulus Y is equal to F by A into L by E. This is the Young's modulus. Young's modulus Y is equal to F by A into L by E. So F is nothing but here tension T. Therefore, V is equal to root over T by rho m. No? So V is equal to root over, instead of F you write YAE by L into M. So that you can write. So YAE. Shall I repeat this one again?
Yes, sir. Repeated it again.
Shall I repeat?
Yes, sir. Repeat.
Okay. See here. I'll write again. I'll write here. See. So again I'll write that one. Again I'll write. See. Y is equal to F by A into L by E. Y is equal to F by A into L by E. So I'll do one thing. I'll take that one more pen, that is 1 minute. So stroke. Stroke size I want to reduce. Okay. See, Y is equal to F by A into L by E. Is there no? From this, F is equal to YAE by L. Okay. F is nothing but tension T. So therefore, velocity V is equal to root over T means you write like this, YAE by L into mass means that is linear density, that is mass per unit length. Mass per unit length, like this is that. Now you cancel this length and length, and this area into elongation will give you volume. So velocity V is equal to root over mass per volume is nothing but the density rho. Therefore, Y divided by rho. What is rho? This is the density. Rho is equal to mass per volume. This is in kg per meter. So instead of Young's modulus, I have written that rigidity modulus of rigidity. Modulus of rigidity by rho. Any doubt now?
No, sir.
No, sir.
Right. So velocity is equal to Y by rho or rigidity by rho. Very important. This is. So V is equal to root over eta by rho. Eta is the modulus of rigidity. Rho is the density of the material. Now, speed of longitudinal waves in motion, some correction is there. That correction they have given, end correction in a solid medium, V is equal to K plus 4 by 3 eta by rho. K is the bulk modulus. And it is the modulus of rigidity. Bulk modulus is nothing but K is equal to what you know, minus P. What is the bulk modulus? Minus P by delta. What is the bulk modulus? Minus delta V by V. Is it correct or not? Shall I repeat? That is, so this bulk modulus I am writing. So this bulk modulus. So bulk modulus, Ramesh.
So delta P upon delta V upon V.
Yeah. So delta bulk modulus K is equal to how much it is? Delta P.
V upon delta V upon V.
Yeah. So that is P into V by delta V. Delta V by V means V by delta V. Is it correct or not?
Yes, sir. Correct.
V by delta V. Is it correct?
Yes, sir.
Right. So this is the bulk modulus. So bulk modulus and modulus of rigidity. So this is the correction. Ramesh, ఈ క్లాస్ రూమ్ లోకి రా, పక్క క్లాస్ సెకండ్ ఫ్లోర్ లో ఉన్నాయి, సెకండ్ క్లాస్ ఆఫీస్ పక్క రూమ్ లోకి రా, ఆఫీస్ పక్క రూమ్. దాని యువతల రూము వైట్ హౌస్ ఆ డోర్ తీస్తుంది. So next one is, this is the y by rho, Young's modulus. In terms of Young's modulus, see here. So in terms of Young's modulus, so this is the Young's modulus. V is equal to root over y by rho. V is equal to root over y by rho. V is equal to root over y by rho. See, very, very important. So first equation, this is V is equal to root over T by rho L or M. And the next equation, this is long bar in metal, long bar, V is equal to root over y by rho. In liquid, velocity V is equal to root over K by rho. What is K? K is the pressure. Pressure divided by rho. Gases also K by rho. K is the pressure. Okay. So in
Yes,
liquid, it is K is the pressure. Please note down all these values. Have you completed? Have you written all these values? Please note down all these values. Please complete all this. From here, first one, second one, and this one, complete. Meghana, good evening. Meghana, good evening. Meghana, assist me. No mundu net open.
Good evening, sir.
Meghana, you put the message to Divya and others. Please join in the class immediately. Put the message in the group.
Yes,
Put the
sir.
message. Now you put
Yes,
the.
sir.
నువ్వు ఫస్ట్ ఏం చేయాలంటే నెట్ ఓపెన్ చేసి టర్మ్ 2 ఫస్ట్ ఇయర్ టర్మ్ 2 ఇందులో కాదు, ఇది పక్కన పెట్టుకుని నెట్ లో ఫస్ట్ ఇయర్ 11th క్లాస్ టర్మ్ 2 సిలబస్ కంప్లీట్ గా ఫిజిక్స్, కెమిస్ట్రీ, బయాలజీ ఓపెన్ చేసాయి. వాటిలో ఫస్ట్ చాప్టర్స్ ఉంటాయి, అవి దీంట్లో నుంచి తీసుకో. ఫస్ట్ చాప్టర్స్ క్వశ్చన్స్, ఇది పెన్ను కాదు, ఫస్ట్ చాప్టర్ క్వశ్చన్స్. ఇప్పుడు టర్మ్ 2లో నాది 8:30 అవుతుంది. పాయింట్ అర్థమైందిగా. టర్మ్ 2లో ఫస్ట్ చాప్టర్ ఫిజిక్స్, కెమిస్ట్రీ, బాటనీ, జువాలజీ తీసి ఒక ఫైల్ చేసుకో సరిపోతుంది. ఎస్, ఎనీ డౌట్? ఎస్, ఎనీబడి హ్యావ్ ఎనీ డౌట్? Asma,
Yes,
completed
Yes,
all
sir.
this,
Yes, sir.
right?
Yes, sir.
Next, velocity of sound in elastic medium. In elastic medium, it is very important. In elastic medium, velocity of sound in elastic medium. That is V is equal to root over E by rho. E is nothing but elasticity of the medium. Elasticity of the medium. E is the elasticity of the medium. E is the elasticity of the medium. E is the elasticity of the medium. Okay. Prakshi Chaudhary, good evening. Okay, right. Next. So, elasticity is more in solids. See, elasticity is more in solids than in liquids, than in gases. So, velocity of sound in steel is 5000 meter per second. In water is 1500 meter per second. In air is 330 meter per second. Steel. So because of that, why? Because sound waves are mechanical waves. To propagate the sound wave, we need the material medium. So velocity of sound is more in solids than in liquids, than in gases. Velocity of sound is more in solids than in liquid than in gases. In steel, 5000 meter per second. In water, 1500 meter per second. In air, 330 meter per second. Okay. Right. Next.
Yes,
This,
sir.
this they ask one time. This question, Newton's formula. Newton will come in all subjects here. I think Newton came in chemistry also. Newton's law, sir. Newton. In physics,
Yes, sir.
in radioactivity is there. In thermodynamics
Yes, sir.
is there. In mechanics
Yes,
is
sir.
there. Yeah, anywhere you go, Newton's laws, Newton is there. Newton's corpuscular theory is there. Even in light also, Newton will enter. Here also Newton entered. See, Newton formula. So Newton's formula. So he assumed that when a sound propagates through air, temperature remains constant. He assumed that whatever he find that Newton, I think many of our students, I think out of these 13 students, I think some are favorite of that Newton, of course, I don't know. But always Newton will do some correction here, not direct equations. So here also, he assumed that sound propagates through air with the temperature remains constant. Temperature remains constant means isothermal process. Temperature remains constant means isothermal process. Isothermal process means there is exchange of heat between system and surroundings. So it obeys the Boyle's law. PV is equal to nRT, T is constant. So PV is equal to constant. By using that equation, that he used that K is nothing but pressure. That is simple equation. Can you understand? So
Yes,
he
sir.
assumed that when sound propagates through air, temperature remains constant. That is, the process is isothermal. Isothermal means it obeys the Boyle's law. So for that equation, he found that velocity is equal to root over P by rho. P is nothing but pressure. P is the pressure. P is the pressure. P is the pressure. So P is the pressure. Any doubt? Please ask me.
No, sir. No doubt.
But some Laplace is there. Laplace is the mathematician. Laplace is the mathematician. He has a very intellectual knowledge. So he used that mathematical calculations and he considered that temperature also, and he did this experiment in adiabatic process. Adiabatic process. In adiabatic process, the isolated system. Adiabatic process is related to the isolated system. Means there is no exchange of heat between system and surroundings. There is no exchange of heat between system and surroundings. So the heat energy given to the system is equal to 0. Is it correct or not? So
Yes, sir.
there you will get PV power gamma is equal to constant. So according to that adiabatic process, we can write that is PV power gamma is equal to constant. So PV power gamma is equal to constant. So Laplace, he corrected that equation, that Newton's formula. Instead of P, you have written that gamma P. Gamma P. So that's only Laplace correction. Laplace correction. He modified Newton's formula. He modified Newton's formula, assuming that propagation of sound in air as adiabatic process. Adiabatic process. Adiabatic process, that is. So adiabatic process, and he has taken that equation C, effect of density with respect to density. He has taken velocity V is equal to root over gamma P by rho. Gamma P by rho. And velocity is inversely proportional to 1 by rho. Velocity is inversely proportional to 1 by rho. See, effect of pressure. So he has written V is equal to gamma P by rho. But you know, PV is equal to nRT. So instead of PV is equal to nRT, for that equation, we can write this equation I am writing. How he has written C. V is equal to root over gamma into, instead of P, he has written PV is equal to nRT, no? So PV is equal to nRT means P is equal to RT by V for 1 mole. So gamma into RT by V into density means that is mass per volume. So volume gets cancelled. So he has written that equation as gamma into RT divided by M. That is the equation. This is. Any doubt? Please ask me. Any doubt? Please ask me. Meghana, have we put the message? Put the message to Divya and Jignasa and other people to join immediately.
I did, sir.
Immediately you call that Jignasa also.
Okay, sir.
So this is the equation. So V is equal to gamma RT divided by M. Any doubt? Anish? Anish is there? Anish is not there. Pawan is there?
Yes, sir.
Right. Pawan, I think Prakshi Chaudhary. Prakshi Chaudhary, sorry, I am forgetting you. You are attending regularly. You are attend regularly. Okay. I forget you. Sorry. Prakshi Chaudhary is also good. So this is the velocity equation. Next, in temperature, gamma RT by M that you had taken T. So V is proportional to root T in kelvins. In Kelvin. So velocity of sound is directly proportional to square root of the absolute temperature. Any doubt? Please ask me. Right. So velocity of sound we can write like this also. How you have written this one? That is alpha is the temperature coefficient. Alpha is the temperature coefficient of velocity of sound. How you write the velocity of sound? I told you that the velocity of sound is highly sensitive with the temperature. Keep this point, please, all of you. The velocity of sound is highly sensitive with the temperature. So because of that, we have to give more respect to the temperature in case of the velocity of sound. In case of the velocity of sound, I'll repeat. According to Newton's, he neglected the temperature. Newton neglected the temperature. He has taken the temperature remains constant in isothermal process. It is very easy. Isothermal process means there is no exchange of heat between system and surroundings. There is exchange of heat between system and surroundings. So there is a temperature constant between the system and surroundings. So it obeys the Boyle's law. It is the slow process. Temperature remains constant. For that, he used that equation velocity V is equal to root over pressure P divided by rho. But Laplace did that experiment mathematically, and he did that experiment and adiabatically also in adiabatic process. Means there is no exchange of heat between system and surroundings. So for that, he has given that equation velocity V is equal to root over gamma P by rho. Gamma. What is gamma? Cp by Cv, that you know. So gamma P by rho. He has written that velocity modified equation V is equal to root over gamma P by rho. From that, we derived all these equations in terms of PV is equal to nRT. From that equation, we have written that velocity in terms of gamma RT by M. And all these are constants, gamma and R. For monatomic gas, what is gamma? For diatomic gas, what is gamma? You know. For monatomic gas, what is the gamma? 5 by 2. And diatomic gas, that is 7 by 5 or something is there. So that is the gamma value. And R is the gas constant, universal gas constant. So this is the mass. By taking all values are constant, velocity of sound is directly proportional to the temperature. Square root of the temperature. Very, very important. So it is highly sensitive with the temperature. So you have to start with 0 degree centigrade onwards. 0 degree means how you got this equation, that I will tell you. Please see. Let V0 is the velocity of sound at 0 degree centigrade. V0 is the velocity of sound at 0 degree centigrade. And Vt is the velocity of sound at T degree centigrade. At T degree centigrade. Then the coefficient of velocity of sound, alpha. The coefficient of velocity of sound, alpha is equal to Vt minus V0 divided by V0 into change in temperature, that is T. Change in temperature, that is T. Okay. So V naught into T. This is alpha per degree centigrade. Now if you take all these values in this side, so alpha into V naught into T is equal to Vt minus V naught. V naught also you can take this side, then you will get that Vt is equal to V naught into 1 plus alpha into T. That is the equation he has written here. Very, very important. Similar to coefficient of linear expansion. Coefficient of linear expansion, we can start anywhere onwards. But coefficient of volume expansion, coefficient of pressure expansions are there, no? So there we can use like this. So coefficient of volume, why? Because gases are also highly sensitive with the temperature. Gases are also highly sensitive with the temperature. You have to start with 0 degree centigrade onwards. You have to start with 0 degree centigrade. I'll repeat, don't be confused. In case of gases, coefficient of volume expansion of gas, alpha, there also we can term as alpha. Coefficient of pressure expansion of gas, beta. For these two, you start with 0 degree centigrade onwards. You start with 0 degree centigrade onwards. Not only these two, one more I will tell you, that is coefficient of resistivity. In case of resistors,
Yes, sir.
coefficient of resistivity also highly sensitive to temperature. I explained. In
Yes,
term
sir.
1, I explained term 1. So
Yes,
there
sir.
also you have write the same thing. There also. All these are sensitive with the temperatures. So because of that, you start with 0 degree centigrade onwards. Okay. And coefficient of thermal conductivity also. Coefficient of thermal conductivity. There also you can use the same thing. Compulsory one question will come based on this. Okay, right. Next, that alpha wheel is approximately 0.608 meter per second per degree centigrade, that is. So these are the things, and that is gamma RT by M. And sometimes you can write that is as a in terms of KT, thermal conductivity. So you can write velocity of sound is equal to KT by M, means thermal 3/2 KT by M. So that you can write, then VRMS by V sound you'll get, this is very important. VRMS by V sound is equal to root over 3 by gamma. 3 by gamma. Any doubt, please ask me.
No, sir. No doubt.
Right. And one more point, this point also you can take. This one, which one? See, this is the wind. Suppose source is moving in this direction. This is the direction of the source. Wind is moving in this direction, which makes an angle theta with respect to the velocity of sound. So velocity of sound is in this direction. This is the velocity of sound. Wind is blowing in this direction, which makes an angle theta. Then we can resolve into two components. That is, this is wind V cos theta and this is V sin theta, of course. So this vertical components gets cancelled. Just you have only V cos theta. Then velocity of sound you can write V plus or minus W cos theta. What is W? That is the wind velocity. So if wind has given with some angle, then the velocity of sound, effective velocity is equal to V plus or minus W cos theta, depending upon the direction of the wind. So that also you can consider. See here. So this is V plus W cos theta. Effect of wind velocity. Effect of wind velocity. Have you completed?
Yes, sir.
Right. You're not that much important, of course. So these are the progressive waves. Please you write progressive waves. Already explained these things. Next side heading is progressive wave. Progressive wave. Progressive waves. See, y is equal to a sin omega t minus kx. What is k? Propagation constant, that is. K is equal to 2 pi by lambda. So that equation we can modify it as y is equal to a sin omega t minus 2 pi by lambda into x. And what is omega? Omega is equal to 2 pi by capital T. That is equal to 2 pi into n. N is nothing but frequency. Here they have written that n as this n they have written as 2 pi into nu. They have written nu is nothing but frequency. See here, they have written omega. Instead of omega, they have written 2 pi by t. 2 pi they have taken as common. Why? Because k is 2 pi by lambda into x. In this case, instead of omega, they have written 2 pi by t minus 2 pi by lambda into x. 2 pi has taken as common. Then small t by capital T. What is capital T? Time period. What is small t? Time of instant minus x by lambda. This is very important formula. 2 pi has taken common. Now 2 pi by lambda if you take as common. So 2 pi by lambda if you take as common, then here you will get velocity. How you get velocity? See, this equation I am converting. This one you see. 1 by time period is nothing but frequency. So 1 by time period is nothing but frequency. So 1 by time period is nothing but frequency. So V is equal to nu lambda. This is V. V is equal to nu lambda. Nu is equal to V divided by lambda. V divided by lambda. So for that, if you write that equation, this equation or omega, you can write like this also. See, this equation 1 by time period is nothing but nu. Nu is equal to V by lambda, means V by lambda minus 2 pi by lambda into x. From that he has taken outside 2 pi by lambda he has taken. Then Vt minus x we get. And also here omega if you take as common, t minus this 2 pi by lambda already I explained that 2 pi by lambda is omega by V. How you got this equation? Omega by V, how you get? Shall I explain? That is C. So omega, C, omega is equal to 2 pi by capital T. You write like this. And velocity V is equal to V by lambda, means V is equal to N. N means frequency, that is lambda by T. Lambda by T. So T is equal to lambda by V. Here T is equal to 2 pi by omega. So this is equation number 1. It is equation number 2. Equate those two. 2 pi by lambda is equal to lambda by V. 2 pi by lambda. Otherwise, you do one thing. Instead of t, you write equation. Here is there no. Instead of t, you write the equation. Omega is equal to 2 pi by lambda into V. Enough. So omega is equal to 2 pi by lambda into V. That's what I have written here. Instead of what is that one? 2 pi by lambda. Instead of this 2 pi by lambda, you write omega by V is equal to 2 pi by lambda. So that is substituted here. Instead of 2 pi by lambda, what you have to write? That is omega by V. Omega you take as common, so T minus x by V. That is the answer. Any doubt?
No, sir.
No, sir.
Right. So
No,
you
sir.
yeah, you finish all these equations. Please, you finish all these equations. You finish all these equations first of all. Have you completed?
Wait, sir.
Okay.
Done, sir.
Right. Next. These are the equations what I have written. Omega is equal to 2 pi n, that is equal to 2 pi by t. V into k. Like this, sir. K is equal to 2 pi by lambda. If you want to write all these things, if you want to write, please. Omega values, k values, v values. V is equal to L lambda. That is the wave velocity. You want to write means you write.
Yes, sir. Wait, sir.
Completed all.
Wait, sir.
Okay, okay, Pawan.
Done, sir.
Okay. Wave number is nothing but reciprocal of lambda. Please mention this one also. Wave number is 1 by lambda. That is the wave number. Wave number is 1 by lambda. All these things. Have you completed all?
No, sir. Wait, sir.
Uh,
Done, sir.
okay. This. Have you completed? Phase difference is equal to 2 pi by lambda into path difference. Phase difference is equal to 2 pi by lambda into path difference. Phase difference is equal to 2 pi by lambda into path difference. Time difference is equal to, this also very important. Time difference is equal to T by lambda into path difference. It is the phase difference, it is the time difference. Time difference is equal to T by lambda into path difference. This is also important. Okay.
Okay, sir.
Right now, problems. Do some problems, please. On this, do some problems. Take this problem. Speed of wave in a certain medium is 3 meter per second, 960 meter per second. If 3600 waves pass over a certain point of the medium in 1 minute, then the wavelength is. The speed of wave in a certain medium is 960 meter per second. If 3600 waves, 3600 waves pass over a certain point of the medium in 1 minute. In 1 minute means the frequency you have to find. Number of waves per second. Frequency is nothing but number of waves per second. Number of waves per second. That is 3600 divided by 60 you have to take. Frequency is number of waves per second. So you find the frequency and then you find the wavelength. Okay.
Yes, sir.
Right. Next question. Go for next question. See, a simple harmonic progressive wave. You write a simple harmonic A simple harmonic progressive is represented by the equation y is equal to 8 sine 2 pi to 0.1x minus 2t, where x and y are in centimeters and t is in seconds. At any instant, the phase difference between the two particles is separated by 2 centimeters, means lambda delta x they have given in the x direction is phase difference they are asking. Path difference they have given. Delta x is equal to 2 centimeters. Now they are asking phase difference. Phase difference is equal to 2 pi by lambda into path difference. Do it please. What is lambda? By using this equation, you have to find out the lambda. How to find the lambda? How to find the lambda? See, this equation you can compare. That's the equation, no? So that equation you can compare. How you compare that is? This is equation, you know, y is equal to a sine 2 pi. You take as common t by small t by capital T minus x by lambda. X by lambda. Okay? X by lambda. Means that here 2 is equal to 1 by lambda. So for that you can find the value. How much you got?
Sir, 1 by 2.
Yeah, see, lambda 10. Answer is 2 by 5 into 180 degrees, 72 degrees. Did you get this?
Yes, sir.
Any doubt?
No, sir.
Right. Next problem. The frequency of sound waves is n and its velocity is v. If the frequency is increased to 4n, the velocity of the wave becomes 2. Velocity of the wave becomes 2. See, the frequency of sound. The frequency of sound wave is n and its velocity v. If the frequency is increased to 4n, the velocity of the wave is, what is the velocity? Velocity does not change in frequency.
Not in yes, sir. V.
Yeah,
Answer is
that
V.
yeah. Please write this statement. Wave velocity does not depends on the frequency. Wave velocity does not depends on the frequency. It depends upon the elasticity and inertia of the medium. It depends upon the elasticity and inertia of the medium. Very important. Very important. Next equation.
Yes, sir.
Next, you do this one, problem number 5. Last problem today. I think many of the students are absent. Only 8 students are there. Only 8. Only 8 students are there. Even ask for, right. Keshav.
Sir,
Okay. Good evening.
good evening, sir.
Right. So we'll complete one problem. We'll finish one problem and we'll close this session. And again, we do all these problems tomorrow. Okay, Pawan?
Okay, sir.
Why? Because many of the students are
Yes,
left.
Yes, sir.
So you take one problem and we finish it. So any one problem you can take. See, IIT problem you can take. In IIT problem, this is the equation. Or the equation here. See, In the wave motion, y is equal to a sin kx minus omega t. Y can represent as. What is this y? Y is like electric field, magnetic field, displacement, pressure, anything. All
Yes, sir.
equations we can represent. Answer is A, B, C, D.
Yes, sir.
Next equation you see, next seventh problem is the last problem today. Seventh problem, very important problem. See how they are asking in the IIT model. Find the ratio of the speed of sound in nitrogen gas. Nitrogen gas, that of helium gas at 300 Kelvin. At 300 Kelvin. At 300 Kelvin. See, find the ratio of the speed of the sound. Find the ratio of the speed of sound in nitrogen gas to the top helium gas at 300 Kelvin is. The velocity of sound V is equal to root over gamma RT by M. Is it correct, Pawan?
Yes, sir.
Yeah.
Correct.
Gamma nitrogen by gamma helium into mass of the helium by mass of the nitrogen.
Nitrogen, yes.
Yeah. What is gamma? Is it diatom? What is nitrogen? It is diatomic or monoatomic? Nitrogen.
Sir, monoatomic.
Nitrogen gas is monoatomic or diatomic? Yeah.
Sir, diatomic. Sorry, sir, diatomic. Yes, sir.
Diatomic means, yeah, gamma value for diatomic is 7/5.
7/5, yes, sir.
Helium is monoatomic.
Yes, sir, yes, sir.
That is 5/3. And mass of helium is 4. Mass of nitrogen atom is 28. Now answer is root over 3/5. Very important question. Keshav. Keshav,
Sir,
you write this equation, this question. It is also related to thermodynamics. This question
Okay,
also
sir.
related to thermodynamics. Please read. Find the ratio of the speed of sound. Find the ratio of the speed of sound in nitrogen gas to that of helium gas at 300 Kelvin. At 300 Kelvin. Find the ratio of the speed of sound in nitrogen gas to the top helium gas at 300 Kelvin. So this is the formula. V is equal to gamma RT divided by M. V is equal to gamma RT divided by M. For that you can find root over 3/5. And I'm requesting all of you who are here, that Pawan and Doleshwar and Sprakshi Chaudhary, all of you, I'm requesting tomorrow, sure, we will start the session at 8 a.m., not 7, 8. 8.
Okay, sir.
So we will finish all these. Many problems are there. Here, see. So many problems.
Okay, sir.
So here, see, all these problems are there. We have to finish all these problems. Tomorrow we will finish all these problems. Same way in SHM, same way in nuclear physics also. So we will project the problems and we have to do without solutions. Here the solutions are there, but tomorrow I remove the solutions. Only I'll give the questions. You have to practice. Okay.
Okay, sir.
This process is good or not?
Yes, sir.
It's okay
Good.
for all.
Yes, sir.
All right. Tomorrow we'll follow the same procedure. Only for problems. Only for problems. Okay. Right. Bye.
Okay.
Good night.
Yes, sir.
Except Keshav, please all of you leave the session. Except Keshav. Why? Because I'm teaching him that thermodynamics. Remaining all, please leave. Keshav?
sir.
Yeah, I think yesterday I explained about the process, adiabatic process equation of completed.
Sir.
Now, adiabatic process is completed yesterday. Now you go for heat engine. Next you go for heat engine. Heat engine. Right. Okay. Keshav,
Sir.
don't make noise. You are making noise.
Okay, sir.
Right. Right. Now you take heat engine. Today we'll finish the heat engine. Heat engine. Heat engine. Carnot engine is the heat engine. Please you write that. Heat engine means. Definition you can write.
Hello, sir.
A device.
Hello, sir.
Yes.
Heat engine is not included in weekend test, sir. Heat engine is not included in tomorrow test, sir.
Which one you have your test? Which topic is
Up
having?
to heat engine, sir. Thermodynamics full chapter up to heat engine.
Okay, okay. So I think energy also is there, energies. A process,
Yes, sir.
isothermal and adiabatic process are there.
There, sir.
Okay. So we do one thing. Okay. So that process I explained. Now you see some formulas graphs. Graphs compulsory they will ask tomorrow's exam. So you write comparison of the slopes of comparison of the slopes of an isothermal and adiabatic PV graphs. PV means pressure and volume graphs. PV graphs are there. So pressure and volume graphs are there. So simple concept I will give you. So in PV graph, so you take here you take it is P and it is V, PV graph. So suppose they will give two waves like this. This is equation number 1 and it is equation number 2. If they will give the graph like this, in isothermal process, it takes more energy. In isothermal process, it takes more energy. Why? Because there is exchange of heat between system and surroundings. So out of these two, the first one is the isothermal. This is the isothermal. And second one is the adiabatic. This is adiabatic, this is isothermal. When piston is moving away, means work done is positive. Work done is positive means this is isothermal and it is adiabatic. It is a reversible process. Irreversible process. In reversible process, see, in reversible process they will give it is volume and it is pressure. Suppose they will give two like this, two signals. In reversible process, this is 1 and it is 2. In this case, in reversible process, 1 is the adiabatic process. Adiabatic. This is adiabatic process. And this is isothermal process. Isothermal process. So, if volume will increase, then if it goes on increase the volume, this is the isothermal process, this is the adiabatic process. If volume will reduce, pressure will increase, then this is the isothermal process and it is the adiabatic process. You take these two graphs. Compulsory they will ask this question tomorrow. Keshav.
Okay, sir.
Next question you write. We'll do some problems based on this. So you write one problem. A gas undergoes a change of state. A gas undergoes a change of state. A gas undergoes a change of state during which 100 joules of heat, 100 joules of heat is supplied. 100 joules of heat is supplied to it, and it does 20 joules of work. 20 joules of work. Full stop. The system is brought back to its original state. The system is brought back to its original state through a process during which 20 joules of heat 20 joules of heat is released. 20 joules of heat is released. 20 joules of heat is released by the gas. What is the work done? What is the work done by the gas? What is the work done by the gas in the second process? Keshav,
Sir.
that problem is check your material. Check your material. Problem number 13.19. Example
13.19.
13.19. Problem is 13.19. Check the problem. 13.19. T,
Sir.
a gas undergoes a change of state during which 100 joules of heat is supplied to it, and it does 20 joules of work. 20
Sir,
joules.
it's 13.17, sir, in my method. 13.17.
13.19.
Okay, sir.
13.19. Question number 13.19. Okay.
Okay, sir.
See there, a gas undergoes, means they have given the gas here, and heat has given that a dq is equal to 100 joules. dq is equal to 100 joules. Okay, supplied to it, and it does 20 joules of work. Means the piston is here. The piston is moving from V1 to V2. That is P into dV. That is dW. That they have given 20 joules. 20 joules of work. The system is brought back to its original state. The system is brought back to its original state. Means that, see here, if you draw the graph, it is volume and it is a pressure. That is volume and it is a pressure. First, this is point A, it is point B. So volume has increased like this. And then what happened? It is brought back to its original state. It brought back to its original state like this. Means it is coming back. So it is coming back means in cyclic process. In cyclic process, what is the internal energy? du is equal to 0. Keshav, that is a very important point. In cyclic process, du is equal to 0. Why? Because change in internal energy is 0. It started here and again it is coming back. So then you write the equation dq is equal to du plus dw. Here du is 0. Therefore dq is equal to dw. But heat is given to the system 100 joules. So work is done by the system is negative. So because of that, work done is equal to here. So work done is equal to minus dq. Why? Because here work done by the external agency against the field. That is minus 100 joules. Answer is. So work done is equal to minus 100 joules. Why? Because dq is 100. dq is 100. That is the work done by the agency against the field. Work done by the agency against the field. That is 100 joules. Minus 100 joules. Answer is minus 100 joules. Okay, na? Keshav.
Okay, sir.
Right. Next, we do some problems on this. From beginning onwards, we'll do some problems. See. I'll tell you the question number. Question number 13.6. Question number 13.6. Question number 13.6 you take, please. Question number 13.6. Question number 13.6. Question number 13.6. What is the question number 13.6? You see, a gas expands from 10 liters to 20 liters. A gas expands from 10 liters to 20 liters. A gas expands from 10 liters to 20 liters at a constant pressure of, pressure is constant, at a constant pressure of 2 atmosphere. At a constant pressure of 2 atmosphere. Please stop. What is the work done by the gas? What is the work done by the gas during the expansion? What is the work done by the gas during the expansion? And they have given 1 atmosphere is equal to 1.013 into 10 to the power of 5 Pascal. 10 power 5 Pascal. What they are asking? Work done. Work done they are asking. So the piston is moving from V1 to V2. V1 to V2. So there is a change in volume by putting pressure as constant. P constant. Therefore, work done is equal to P into dV. What is P? 2 into atmosphere you can convert, that is 1.013 into 10 power 5 into dV. dV is nothing but V2 minus V1. That is V2 minus V1. That is equal to 2 into 1.013 into 10 to the power of 5 into what is V2? 20 minus what is V1? 10 into liters. You can convert into liters. Is there? No. Liters you can convert it into meters. So liter you can convert it into meters. 1 liter is equal to 10 power 3 centimeters. That also you can write, please. 1 liter is equal to 10 power 3 centimeter cube. That is equal to 10 power 3 into 10 power minus 6 meter cube. That is equal to 10 power minus 3 meter cube. 1 liter is equal to. You write this one also. Keshav.
Sir.
You write this one also. 1 liter is
Okay,
equal to 1 liter. 1 liter is equal to 10 power 3 centimeter cube or 10 power minus 3 meter cube. So here you can convert it into meter cube, means 10 power minus 3. Do it. How much you get? Do it. What is the answer? What is the answer?
Sir, 2.026 into 10 power.
How much?
2.026.
Yeah, 2.02 into 10 power 3 joules. Correct only. 2.02 into 10 power 10 power 3. 10 power 3 joules, right? 10 power 3 joules. This is the work done. Very good. Next problem. Completed, huh?
Completed, sir.
Next problem. Next problem is problem number 13.7. Problem number 13.7. Problem number 13.7. Problem number 13.7. What is 13.7c? When heat energy of 1500 joules, when heat energy of 1500 joules is supplied to a gas, when heat energy of 1500 joule is supplied to a gas, when heat energy of 1500 joule is supplied to a gas, the external work done on the gas is 525 joules, 525 joules. What is the increase in its initial energy? What is the increase in its internal energy? What is the increase in its internal energy? Means the question will be like this. So this is the gas, it is the volume V1, heat as given, that is dq. dq is equal to how much? That is 1500 joules. 1500 joules. By giving heat, here du is there, and then the piston is moving from V1 to V2. This external work done also they have given. External work done is equal to 525 joules. 525 joules. Now they are asking this internal energy. You know the dq is equal to du plus dw. Now du is equal to dq minus dw. dq is 1500 joules. dw is 525 joules. Then you can find du. Do it. Next question is very important question.
975 joule.
Yogita,
Yes,
Yogita,
sir.
are you able to write the question?
Yes.
I am actually that boy has material. So that boy is having material because shall I teach? Shall I dictate the question, Yogita?
So you already dictated the question, so I write it.
Yes, sir.
Yes, sir.
If you want means I will dictate. Do you have interest means?
Yes, sir.
Akshi Chaudhary, Pavan, Yogita. If you want means I will dictate the question also.
Sir, you are
You are dictating, sir.
already.
Okay. Okay. Next question. You write the next question.
Dictated question, na?
Okay. Next question. Answer Keshav. Keshav.
Sir,
What answer you got?
sir,
Answer.
1025.
Right. Very good. 1025. 1025. Next question. Next question. Okay. I am dictating. Check it. Question of Keshav. Question number 13.8. Question number 13.8. Please write. When 1 gram of water, 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 when 1 gram of water at 100 degrees centigrade, at 100 degrees centigrade, at 100 degrees centigrade is converted into steam, is converted into steam at 100 degrees centigrade, is converted into steam when 1 gram of water at 100 degrees centigrade is converted into steam, steam at 100 degrees centigrade, converted into steam at 100 degrees centigrade, comma, it occupies a volume of, it occupies a volume of, it occupies a volume of 1671 cubic centimeter, 1671 cubic centimeter at normal atmospheric pressure, at normal atmospheric pressure. At normal atmospheric pressure. At normal atmospheric pressure. At normal atmospheric pressure. Full stop. Find the increase in internal energy of the find the increase in internal energy. Find the increase in internal energy of the molecules of steam. Molecules of a steam. du we have to find out.
Sir,
Hmm.
in last question, dV is equals to dq minus dv. W
Yeah,
is 1500 minus 525.
yeah.
Then answer is 975, not 1075.
Answer, that answer is what they did, that is wrong. What you said, that is correct. What you said, that is correct. What is the answer? 1500 minus 1500
525.
525
minus 525.
5 9.
Sir, the answer is 975.
Yeah, 975 joules. In the textbook they did the mistake. Keshav is telling same answer. He did it done. Keshav, you have not done the problem. Just use saw the answer, you know.
No, sir. Du equal to dq plus dw.
Huh?
Du equal to dq plus dw.
Why d plus will come here? dq is equal to du plus dw. dq is equal to du plus dw. Na? Therefore, du is equal to dq minus dw. Huh? Simply you saw the answer, I know. Okay, do this problem. 13.8. Yogita is a good girl here. He identified it. That is, answer is 975. In the textbook, in the material, they did the mistake. Okay, do this one.
Sir,
Hmm.
sir,
Hmm.
sir,
Hmm.
in the first problem,
Hmm.
you find work done is equal. My answer is 60 joule.
Minus which
Sir, my answer is 60 joule.
which question that is?
Sir, in first problem.
First problem. 13.6. Huh? A gas expands from 10 liters to 20 liters.
Yes, sir.
That 13.19, sir.
Yes.
For that answer you want Pawan,
13.9.
which question? Please tell me.
Sir, 13.19.
13.19. Okay, I will go for 13.19. 1 minute. 13.19. 1 minute. Yeah. In 13.19, work done is minus 100 joules. Minus 100. What is the?
Sir.
Yes, yes.
So, but my answer is 60 joule.
Why you are getting 16?
60 joule.
What 16 here?
Sir, his answer is 60 joules.
Why?
Sir, we can use that formula now.
You see. Okay, 1 minute. 1 minute.
Is equals to du1 plus dw1.
I'll come back. This one you are asking, I think. 13.9. 19. 13.19 only.
Yes, sir. They are asking this problem.
Pawan, you are asking this question. Pawan. You are asking this question, huh?
I think there is some problem from Pawan's side in net
Okay, okay, okay,
joining the meeting.
okay. Keshav,
Sir,
ah,
what is the answer? Can you please repeat? I have left the meeting because of network issue.
this question only, no, 13.1 you are asking.
Yes, sir.
See, in cyclic process means the piston is again moving in downward direction. Piston is moving in downward. That is the work done by the external agency on the gas. Work done by the external agency on the gas. Why? Because gas pushed away, and again somebody has pushed this piston in downward direction. This is negative work done. And whenever you come back to this original position, internal energy is 0. Why? Because it started here and coming to B and again coming to A. So change in internal energy. Du is nothing but U final minus U initial. U final minus U initial is equal to 0.
0, yes, sir.
Yeah, therefore dq is equal to, you know, dq is equal to du plus dw. dq is 0. dq is equal to minus dw. Why I have taken minus? That is the work done by the external agency on the gas. By the external agency on the gas, you see, on the gas means work done by the gas is negative. Work done by the gas is negative. Work done on the gas is positive. So here work done by the gas is negative. So that is nothing but minus 100 joules answer. Any doubt?
Sir, here we cannot take first we can find du1 that is equals to 80 joule, and by that concept we can say that du1 is equals to minus of du2, and by putting values that is minus 20 is equals to minus 80 plus dw2. From that we have answer w2 is equals to 60 joule.
No, not like that. Why? Because if you want to write that equation, you write like this. So if you want to write in that way for that question, which question you are asking?
13.19.
Yeah. So if you want to write that question, like the 100 minus 20, you have to write 100
Yes,
minus
sir. 100 minus
20.
20
You
is
write like
equals to du1.
100 minus 20, that is equal to
du1.
minus 20 plus w. Like this you have to write. 100 minus 20 is equal to minus 20 plus. So if you take this side, both gets cancelled. This, so work done is equal to 100 only. In cyclic process, the du is equal to 0, like this.
Yes, sir.
Right. Next question. Keshav,
Sir,
you take another question. Already I have given the question, no?
yes, sir.
1 gram of
Could you
water.
please explain? Sir, could you please explain that question solution?
Yeah, this question I think I have given. Internal energy you have to find out. Do it, please. This is the question. Do it. When 1 gram of water at 100 degrees centigrade, 1 gram of water at 100 degrees centigrade is converted into steam at 100 degrees centigrade, and its volume occupies 1671 cubic centimeter. 1671 cubic centimeter. 1671 cubic centimeter.
Sir, could you please explain the solution?
Yeah, sure. See, so for this, first of all, 1 atmosphere you can take. So this question I am explaining. See, first you can take, you can write 1 atmosphere. 1 atmosphere is equal to 1 point, what is the value? 1.013 into 10 to the power 5 Pascal. 1 atmosphere is equal to 1.013 into 10 power 5 Pascal. Next, volume of 1 gram of water that you have to find out. Volume of 1 gram of water you have to find out. Keshav, how to find means mass of the given gas is equal to mass by volume is equal to density. Mass by volume is equal to density. I'll write like this. Density of water, otherwise. Density of water is equal to mass divided by volume. Okay. So density of water is equal to 1000 kg per meter cube. In SI system, density of water is 1000 kg per meter cube. In CZ system, 1 gram per centimeter cube. So density of water is 1000 kg per meter cube in SI system. This is in SI system, SI unit. And in CCS unit, 1 gram per centimeter cube. That is the density of water. So now volume you have to find out. This mass they have given 1 gram. So volume is equal to, you write like this. Volume is equal to mass per density. Mass they have given 1 gram. 1 gram divided by this density in CCS system, that is 1 gram per centimeter cube. That is equal to volume is equal to 1 centimeter cube. 1 centimeter cube means 10 power minus 3 meter cube. 10 power minus 6. 10 power minus 6 meter cube. So 1 centimeter cube is nothing but 10 power minus 6 meter cube. Why? See, 1 centimeter is equal to 10 power minus 2 meters. 1 centimeter cube is equal to 10 power minus 2 whole cube meter cube. That is equal to 10 power minus 6 meter cube. So 1 centimeter cube is equal to 10 power minus 6 meter cube. This is the volume of the water. Now volume of the steam they have given. This is volume of the water. Okay, volume of the steam they have given. How much they have given? See, volume of the steam they have given. What is the volume of the steam?
1670.
So right, volume of the steam is equal to 1671 centimeter cube. 1671 centimeter cube. Volume of the steam they have given 1671 centimeter cube. That also you can convert it into meter cube. That is equal to 1671 into 10 power minus 6 meter cube. This is volume of the steam. This is the volume of the steam. Now, external work done you can find out. Work done. Work done is equal to pressure constant, pressure into V2. V2 means volume of the steam minus V1 is that what? Volume of the water. So P at normal temperature they have given means 1 atmosphere. 1 atmosphere is equal to, already have written 1.030 into 10 power 5 Pascal. For that you can find the work done first. Please do it. Do this work done first. Do this work done. Do the work done, please. Do the work done. How much you got to work done? That is the external work done, DW. How much you got? This DW you can find out, please. Find this value, all of you. How much you got, Yogita? Yogita is there, huh? Yeah. Yogita, Pawan, Prakshi Chaudhary.
Sir, 1692.7 into 10 raised to the power minus
Yeah,
7.
very good. 169.2 joules.
Yes, sir.
169.2 joules. Right. Very good. Good girl. So that answer is 169.2 joules. 169.2 joules. Now you can find the dq. dq is equal to m.
Sir, could you please explain the answer?
Which one you want?
169.
Yeah, you substitute here, yeah. dw. So dw is equal to, what is p value? This is p value. 1.013 into 10 to the power of 5 into, what is the steam? This is 1671. 1671 minus 1671 minus, this is a 10 power by 6, no, 1671 minus 1 into 10 power minus 6. 10 power minus 6 I have taken as common. That is equal to 1.013 into 10 power 5 into 1670 into 10 power minus 6. So 10, 10 power by 6, everything gets cancelled. That is equal to 1.013 into 167. Do it. I think what that Yogita told, that answer will get. What is the answer? That is 169.2 joules. This is dW. Any doubt?
No, sir.
Right. Now dq can find out. How you can find dq? Water is converted into steam, no? Water at 100 degrees centigrade is converted into steam. So see here. So this is the water. Water at 100 degrees centigrade is converted into steam at 100 degrees centigrade. Means here latent heat of steam is there. That is dq. So dq is equal to ml steam. ml steam. What is m? Mass they have given. What is the value? How much they have given? Mass. 1 gram. How much they have given?
Yes, sir. 1 gram.
So 1 gram they have given. Means 1 into, what is the latent heat of steam? That is 540. Is it correct or not? 540.
Yes, sir. Correct.
540 into grams we have given. That we converted into joules. Joules. That is, you multiply with 4.2. So 540 into 4.2. You do that. This you will get to 2268 joules. 2268 joules. This is dq. Now dq is equal to du plus dw. dw we find it. dq we find right now. Therefore du is equal to dq minus dw. dq is 2268 minus dw is, what is dw value? What is dw? Here you find
169.2.
169.2.
169.2.
Right. Now you can find the du. What is the value? Please do it. That is a 540 calorie per gram that we converted into joules. Means into 4.2 multiply. What is the answer? What is the answer, please?
Sir, 22098.8.
Yeah, answer is 2098, not 22.
Yes, sir, 2098.8.
Yeah, 2098.8, right. The answer is 2098.8 joules. That is the answer. 20. So now I think time is almost all 9 o'clock.
Yes, sir.
So we'll close this session. Okay, na?
Okay, sir.
Right. Okay, Keshav. Keshav,
Sir,
completed.
completed, sir.
Shall we close the session?
Okay, sir.
Right.